So, continuing from the last class, what we saw there is that is what is meant by learning in case of neural network and how it is implemented in a mathematical algorithm. Okay, so repeated training, if you remember, was defined as kind of learning, and that is how the learning was implemented. From the last this one, we'll just once again see how this neural network is actually developed and what are the phases in that. So a neural network essentially developing a neural network will have basically two phases. So neural network actually works in two phases. The first phase we can call it as a training phase. Okay, in the training phase, as just we saw in the earlier lecture, in the training phase what we have is we have the inputs for training as well as the output given to us, and using this input and output information, what we do is we build a network, or rather a artificial neural network, which is in our case what we did was basically adjusting the weight using the adaptive algorithm. So input, output, and I can say plus an algorithm gives you a artificial neural network, and that is the training phase. Once this network is ready, then the second phase, that is actually the use phase, that is the phase in which the actual neural network is being used. Okay, so this was just for training, for developing a network. Once the network has been developed, it works in a recall phase. What do we mean by a recall phase here? Basically what we do is, in recall phase we supply inputs to the network. So since already this network is developed here, okay, it comes over here. So input is supplied to the network, okay, and this network gives you the output, and that is what the recall phase is, that is network in use. So once the training phase is over, we can use the network in recall phase, that is the call phase, that is using of a neural network. Now when you talk about recall, if you see, you can say that if you have to simply give the input and take the output for which the network was trained, then it is better to have a lookup table. Why to have a neural network? Because if you supply the set of input, for all this input you make a lookup table, and you can just see through that input what is there in the lookup table. But when we talk about neural network, recall phase is not a lookup table, but in recall phase we can supply those inputs which were not used in the training phase. Okay, we can also supply those inputs that were not used in the training phase, and for those input also we get output, which is if network was trained properly or developed properly, which would be satisfactory. That means the expected output would come. So that is what we call about, we can say, the phases of neural network. There can be an intermediate phase, which will be, we can call it as a testing phase. Okay, intermediate to this, but it is some people will put that in training phase only. In testing phase is essentially a recall phase in which if it is not performing well, then we change some parameters of the network by changing the number of neurons or something like that, or type of neuron maybe, and it is again trained. So the testing is essentially a recall phase to see the performance of network. If performance is not good, then it goes to training and again testing, and once it passes through these two tests, training and testing, then it can be used in recall phase or in the use phase. So that is how the overall working of a neural network can be put. Now let us talk about how this input and output learning relations are also sometimes termed as mapping. So training means basically mapping the input space into a output space. So same training can sometimes are also called to be mapping. Basically what we are doing, we have a set of inputs here, a space having inputs and a space having outputs, and there is a network in between which maps this input to this output. So this is essentially sometimes called mapping of input to output, is basically the work of neural network. Now, there could be a case where you may have uh, several neurons, several outputs. Okay, so here, if you see, this is now a structure showing you uh, several outputs. Okay, so suppose instead of only one output, which we saw in the last example, we need to have m outputs for given n inputs. Okay, so now we can have that many number of neurons output, and that is how this is the structure of neural network is. This kind of neural networks are called feed forward neural network, or FFNN, feed forward neural network. So basically the input is fed into this and finally the output comes over here. That is what feed forward means here. But in training phase, this is slightly different. We call back propagation network in context of it's training. Okay, back propagation neural network, that means while training we take the output and then through that algorithm we correct the weights. So now the error is back propagated, so sometimes called error back propagation neural network. Or when we talk about recall phase or working phase, then we call it as feed forward neural network. So FFNN or BPNN are basically same, only the context changes that we are referring to its recall phase, or we are trying to talk about its training. So now let's talk about, if you have multiple outputs, then that many neurons would be required, because each neuron can have only one output. But the number of weights could be dependent on the number of inputs. Okay, so here this is the way a single neuron, which we have already seen, would be connected. So this neuron is connected to all the inputs through its weights. Then the second neuron, so this is first neuron connected through its weights. Then if I talk about the second neuron here, then again it is also connected through these weights. Second neuron again will be connected through this, all the weights. So when this happens, that all the inputs are connected to all the neurons, then we also call this kind of network as fully connected. That means all the inputs are connected to all the neurons. So a fully connected architecture. Now if we see the mathematical notion of what is happening over here. So if you see this for one neuron, when one neuron is connected, then this weights will be W11, W12 and W1n. So n inputs are there. So for this neuron, these are the sets of weight put over here. Similarly, when I go to second one, then this is the weights for all the n inputs, third one. So finally, this neural network having multiple input and multiple outputs are defined in terms of weight matrix. And this is essentially a weight matrix, if you see. So that is how the weight matrix of a neural network is. So here it is showing all the connections and weight matrices. Now sometimes this mapping from input to output is done, and then we are not interested that what is inside this. Inside this network, basically this is said to be a black box. Okay, so if you see, this is basically mapping of this set of inputs to this output space. So input to output space is a mapping. So this neural network is basically mapping the input space to the output space. So this is the weight matrix, and this is the output for each of this F net. This is F net, this is F net for the third neuron, and this is finally the output for each of the neuron. So this is what the mapping is from input to space to output space. Sometimes the mappings could be quite simple. Okay, mappings could be simple, and sometimes the mapping could be complex. So how when we say mapping is simple or mapping is complex is slightly a loose term, because simple idea through what we mean here is, if a network is not able to map properly the input and output spaces, then we say that the mapping is complex, so you have to have a complex network or a bigger network maybe. Okay, so this is how the complex and simple mapping means. It is in actually relative terms only. So here input and output is there. Now at times, if you are not able to map this input, this is not able to map the input output space fully, that means the network is not performing correctly in a testing phase, then you may at times have a complex mapping network or more complex network. Okay, so now then you have a layered structure. Layered structure. What do we mean by a layered structure? Let me check if I have a diagram for that. Okay, so here if you see, this is a single hidden layer network. What do we mean by single hidden layer network? Hidden layers are those hidden layer is that layer in which you have the neurons put. So if you see in this network, there is one layer of neurons over here. Okay, so one layer of hidden neurons, and this is called the input layer. This is a hidden layer, or you may call it first hidden layer. There is only one hidden, so first hidden layer, then the output of the first hidden layer. Then you may further have a another one more layer of this kind here. Okay, and again output from that, and you can have a multiple layered structure of A and N. So that network becomes complex, and those networks are used for mapping complex mapping of input and output spaces. So let us try to see what is multi-layer feed-forward neural network is. So this is, suppose, the input layer, the first layer where the inputs are there. Okay, so only this part is shown, and from there the weights to different neurons will go. Okay, then this is the input layer. Then from input layer, this is hidden layer. Okay, input layer, then hidden layer, and the output of the hidden layer is output of layer 1, and this can be defined by number of neurons you have in the hidden layer. Okay, so these two could be independent. Okay, so number of input and number of hidden layers. Then the output could be supplied to next hidden layer, so that is hidden layer 2, and output of hidden layer 2, and that serves as an input to the next layer. So every output of a hidden layer can be independently output of a full network, or could also be a input to a next hidden layer. Here you have a 3-layer neural network. Okay, hidden layer 1, hidden layer 2, hidden layer 3, and the final is the output layer. Okay, so depending on the complexity of input-output mapping, you may require different number of layers, and that would only be decided when you start working on a particular mapping problem. Nothing can be decided beforehand that this will require one hidden layer or two hidden layers. You have to first do some kind of hit and trial and decide that how many hidden layers would be required. So one of the important problems with hidden layer is to decide what will be the weight matrices and what will be the size of input at each layer. So for example, here in this case you have a problem here that let's say you have a input layer having three inputs, and the first neuron or a first hidden layer has four neurons, and second hidden layer has one neuron. And can you now tell me what would be the sizes of weight matrices at different hidden layers? Okay, so here as you know, number of inputs are there, number of neurons are there, so a weight matrix will be dependent on the number of input and number of neurons. Okay, so let me call it W1. And then here, depending on how many outputs should be there, that will form an input to the second layer, hidden layer 2. And then how many outputs are there here would decide how many neurons are required over here. So let's try to see this, how it is worked out. Because while writing program, you may have to sometimes decide in certain cases beforehand what will be the weight matrices at different places in a program. So let's say here you have three inputs. So there are three inputs if you see, x1, x2 and -1. The k denotes the instant at which we are supplying that particular input. Okay. And this is the weight matrix now, four neurons and a hidden layer. So this is how it will have. Then you have okay, then you have output layer. There one output would be there, four outputs will be there from the first layer. Okay, four outputs, and then from those four outputs so there would be four outputs, and there will be then one hidden and then from layer 2 there is only one neuron, so there will be only one output, and number of input would be 4 to this layer 2. So the weight matrix or a weight layer would be like this, and this is the output layer of 2. So now you can figure out how these layers would be. Okay, layer 1, I think there is some mistake over here, output layer. So there is 4 is there, 1 2 3 and 4, and there would be one bias layer. Okay, and here similarly, here also there is one bias, so 3 inputs are including the biases. So I think I'll stop here. Thank you.